Hello everyone, I'm Anurag Pathak. In this short sessions of videos, we're going to see some basics of geography. And for that, I have chosen this question for this video, where we're going to see what types of rocks are formed in a hot or deep environment. So we have in some specific regions and areas where we have chances of formation of the rocks. These are volcanic ash, magma chamber, lava, hot springs, and deep within earth. So we'll take one by one. First, we'll see how volcanic ash forms, what type of rocks. So as we know, once the eruption takes place, we have ashes come out, and with that, many fragments, water vapor, chemical compounds, they all turn into one kind of a smoke, volcanic smoke. And when once this volcano and related ash settle down, they turn into a rocks. So geologists, they consider fragments related with the ash, they call it a pyroclast. Pyroclast. And if the rocks forms from this pyroclast, we call it pyroclastic. Pyroclastic rocks. Now, pyro means something associated with an ashes, and then like we have another name of this rock is tephra. So tephra, pyroclast, these are the Greek words that means something related with the volcanic ash. Now these type of rocks forms nearby the mouth of the volcano, and they do not have a specific chemical composition. They are of various sizes. Now in this scenario, we'll see the next area where we have the possible formation of the rock. It is a magma chamber. Now what is magma chamber? As we know, when we go from the crust mantle towards the core, like a solid crust translated into a molten mantle. But sometimes what happened, as thermosphere get melts and it got erupted there towards the surface, and sometimes we have a large portion of this magma get trapped into the earth crust, and once it trapped there in the earth crust, it got detached from the mantle and the cooling get starts. So the rate of cooling is very slow. It takes millions of years to settle down and turn into hard rocks. So this type of rocks, which are associated with the magma chamber, we call it intrusive rocks. Intrusive rocks. So you can find some examples of intrusive rocks. So we have a granite and gabbro. So there you can see when we have an intrusive rocks, their structured grain particles are very small and they are very hard and rigid. Now, magma chamber is normally somehow 6 or 7 kilometers below Earth's surface. Now, let us see the next area where we have chances of rocks to form, and these are the lava. So what is the lava? Once magma come out on the surface, so the portion of the hot molten material on surface is known as a lava. So there is some basic difference between magma and lava. Magma is a pure material, and when this magma melts some portion of the crust, make material impure, we form a lava. So once lava gets solidified, they form on rocks, and these type of rocks are known as extrusive rocks. And we have varieties of extrusive rocks. Some of the common example is pumic stone, and we have a pumic stone, and we have a number of stones are there. For that, I'm going to bring one special video. Now we're going to see another area where we have a possibility of the rocks to form, and this is normally associated with the hot springs. And you might have some idea regarding to the Yellowstone National Park, where we have the molten material is coming into the surface. Once this molten material get solidify, liquid directly turn into a rocks, it forms this type of rocks, and that type of rocks are known as hydrothermal rocks. Now, just want to add one information that some geologists, they keep this type of rocks other than the basic 3 categories of the rocks. Normally, as we know, the rocks are classified as igneous, sedimentary, and metamorphic. In some classification, They consider that as in a fourth category of hydrothermal rocks are the fourth category of the rocks, because here the rocks forms directly from the liquid, like the source is the liquid. Now, you will find the most of this type of rocks associated with the Red Sea. Now, in the Red Sea, we have the many, like a point where the magma, molten magma is coming on the surface, and which makes the possibility of such type of rocks to develop. Now, we're going to see how metamorphism happen. It happens due to the compression of pressure and temperature. Because of the pressure and temperature, the real features of the rocks like change. And when their property changes due to the pressure and temperature, we call it a metamorph. And there in the metamorph, we have, due to the degree of the pressure and temperature, we have a different types of rocks forms. So from the slate to gneiss, you will find these rocks forms under surface. And normally in metamorphic, you can find, because of the compression, we have these designs which show